This video is going to continue right where the previous video left off. We're in the same file, the same Matlab document, part 020 underscore file read underscore find.m, link in the description to all my code. And this time we're going to be looking at random number generation in Matlab. And run this section, Control Enter. All right, the first random number generation function that I'm going to introduce is randi. Randi is used to generate vectors or matrices of random integers. The I is for integer. So the code I've got right here calls the function randi, generates random numbers between 0 and 99, except that's not entirely accurate. It's between 1 and 99 inclusive on both ends. That is not necessarily what most people would expect if you've come from any other programming language. So it's between 1 and 99 inclusive on both ends. I'm going to say more about that. And the two other numbers, 3 and 5, well, what's that about? Well, it generates a 3 by 5 matrix of these values. And every time I run it, it generates a different set of numbers. So I run it again. Now I changed my window width again. I'm going to stop screwing with that so I can see everything on my screen. Control Enter, and just generate new random numbers every time. I'm going to put the results of that, which is a new 3 by 5 matrix, into a variable named randints. Now let's actually change the dimensions so maybe it fits on the screen better. I'm going to just make it a 3 by 2. Run it again. All right, there's my little 3 by 2. And in fact, you know what else I'm going to do? I'm just going to change this next part into a new section, %space, and now we're just dealing with our little 3 by 2 here. Oh, this is going to be so much easier. I should have done this in class today. Anyway, this is a uniform distribution. All the numbers in your distribution are equally likely. We can see this a little bit easier if I change this 99 to just like 2 and then run it again. All right, now it doesn't look like a uniform distribution. It looks like the ones are a lot more common, but you can see we can generate both 1s and 2s here. Change the comment while I'm sitting here just to make sure everything is consistent. All right, but there it's a little bit more even. Run it again, run it again. There it's equal, run it again, run it again. There's more 2s, right? Randomness is random. So it should be, on the long term, a uniform distribution. Now, an important question is, though, what if I want 0 to 99? What if I want to include 0 in my distribution, right? What do I do then? And actually, let's just do 0 to 1 so that we don't get carried away here. If I put 1 in, well, it's always going to be 1 because it starts at 1 and then it goes up to whatever a number I put here. Now, what I can do is I can generate random numbers between 1 and 2, and then I can subtract 1 on the outside. All right, so now I can also generate zeros, and I'll keep running it. And these are just random generations of 1s and 0s. But I would really like a really general formula for how to generate random numbers of all ranges. So let me do this in an organized fashion and create my lower bound. And my lower bound, let's do 5 to 10. I don't know, so lower number is 5, and then my upper bound is going to be, or I'm just going to do low and up. No, low and high, excuse me. Low and high, and my high will be 10. Now, how do I plug these in to whatever formula over here to generate the values that I want? Well, what I want here instead of a 2 is I want high minus low. And that's not all, but I'm going to start with that. I'm actually going to get rid of the negative 1 for now. Let's see how this works. Let's see if this works for us. What does this do? All right, it looks like it's generating numbers between 1 and 5, and that is, in fact, what we're going to get. We're going to get numbers between 1 and 5 if I do it like this. But what I really want is 5 to 10. So the next thing that I'm going to do is I'm going to add the low outside of the parentheses. After I've made this calculation out here, I'm going to say plus low. All right, run it again. Okay, I'm getting 10. Let's see what the low end is. I'm not seeing any 5s as I rerun this. And in fact, I'm not going to get any 5s as I rerun this. So I need to continue to modify this slightly. After the plus low, I'm going to do a subtract 1. Well, now I'm getting 5s, but I'm not getting the 10 on the upper end. Now, what I would do to modify this, I mean, you could just make it 11, but what I'm going to do is I'm going to put a plus 1 in here. It looks not great, but when I run it, I get 10s, I get 5s. It is my interval from low to high. What doesn't look great about it, in my opinion, is the plus 1 and the minus 1. But this is what you get when you don't start at 0. Matlab has made a lot of choices to make it more palatable to people who are not computer programmers. such as starting indexing and also random number generation of integers at 1 rather than at 0. But the downside is then if you want to generate an interval, if you want to generate random numbers between some low and high, your calculation is now more complicated. Also, they made this first input to the randi function inclusive rather than exclusive. This is what I was saying at the beginning when I said like 0 to 99, which was, really wrong. It was actually 1 to 99 inclusive on both ends. Most other programming languages are going to make it exclusive on this end, and by doing so, you don't need both the +1 and the -1 if you just start at 0 and you make this exclusive. But that's the end of my rant here. This will work for you for whatever low to high you want. You want to generate from -5 to +5? Fantastic. You just change these values right here and run it, and it's not quite -5, but it's close, +5. If we keep running it, we will eventually get -5. And there's one right there. Continuing on down. The other random number generation function is just rand, and it doesn't take 3 inputs. It only takes 2 inputs in its parentheses, 2 numbers. The first number is the number of rows, second number, the number of columns. Now, because of my font size, I can't nicely display this, and when I try, it displays out very poorly. But if we also just display out the size of randints and rerun it, we can see that there are 3 rows and 5 columns. And, if I change it to a 4x2 and run it again, it's 4 rows and 2 columns. These random numbers are not integers, as you can see. It is a random number between 0 and 1. It is also a uniform distribution. The random number generation algorithm being used is going to attempt to generate numbers that they're all equally likely. Continuing on down. This is a somewhat made-up example here involving times and temperatures. There's not really that much context to it, but mostly just my variable names are going to use these terms. I'm going to run this section, and then I'll discuss it. Let me scroll up to the top in my command window. All right, so I'm going to create a vector named times, and I'm going to make it an interval from 12 to 24. Maybe we're doing 24-hour time, and we're only interested in these particular hours. And then what I want a randomly generated vector that I'm going to name temperatures. We're going to use decimal values, just 0 to 1 random numbers, but I want it to have the exact same number of rows and columns as my times vector. Now, this is a horizontal vector. It's a row vector. It just has 1 row and many columns. But how many columns does it have? Now, you might think, oh, well, we'll just put a 12 in here and we'll get the right results. But if I try that, I get an error. And part of the problem is there are not 12 numbers in this vector. I mean, it's easy to make that mistake because we look at it and we say, oh, 12 plus 12 is 24. There must be 12 numbers here. But that's forgetting the 12 itself, right? Anyway, you can count them up and you will find out that there are, in fact, 13 total numbers in this vector. Now, of course, you could just put a 13 in here and run it and everything works fine. But the problem with that is, what if eventually we want to run from 1 to 24 or 10 to 16 or some other distribution of times? Well, then our code is brittle. It breaks easily. We want to avoid brittle code. And what we can do to make sure that doesn't happen is instead of some number here, we can do a calculation. We can use a function, such as length, that will calculate how many total values there are in times. And we're plugging the result of that into the rand function. So 1 row, this number of columns. And this will ensure that regardless of how many values are in the times vector, the temperatures vector will have just as many columns in it. Now then I'm going to take these 2 vectors and I'm going to put them into a table using the table function. The table function takes as input column vectors, not row vectors. These are row vectors, so I need to transpose both of them. There are other ways to do this. I could have transposed this earlier. I could have specified that I wanted a length of times, number of rows, and then 1 column. There's different ways. This is how I chose to do it on this example. I just transposed both of them with apostrophes inside the parentheses of the table function. I put the result of the table function in a variable t. I told the properties.variable names of that table that I wanted these column labels. And if I scroll up in my command window, we can see them there. And I have my table. Now I know these are not really reasonable temperatures, but again, just like, bear with me, it's a silly example. Continuing on down, suppose I want to find the maximum temperature and the position, also known as the index, at which it occurs. So I want to know, where is that maximum located? What I can do is I can use the max function on the temperatures vector. And on the left side of the equal sign, I can use two different variables. I just named my variables highest temp and index. Because of the font size I'm using, I do regret that, and I wish I'd used shorter variable names, but we're going to deal with it. And then I can display out my results. Highest temp is going to be the maximum. Index is going to be the position at which it occurs. Let's scroll down in our command window and see where it did occur. So this was the highest temperature, and it was the 8th element. Now, if you didn't get that when you ran your code, that's because there's randomization involved. You're going to get a different temperature. You're probably going to get a different position of that temperature. By the way, I'm using some fancy displaying right here. Not terribly fancy. I don't actually like this, but if you're wondering how can I display out numeric information and text information on the same line, this is one way to do it, and I will discuss other ways to do it in later videos. So it's still a display with parentheses. The awkward part is that we then need square brackets inside those parentheses, apostrophes around the text to display. The comma is actually optional, but I like it. And unfortunately, we can't then just put a number in. If we try, weird stuff might happen. So if I run that without the num to string function, it does run, but there's just a big old blank right there, which is not ideal. So I'm going to undo that, Control Z to undo. I'm going to put back in this function, which is an abbreviation of number to string. It converts from numeric to string or text data. Now, because this is already too wide for my screen, I then used the ellipses, ... to move down to the next line, and I displayed the rest of the text inside the square brackets, inside the parentheses on that line. Now, what if we further want to ask, at what time does the highest temperature occur? In order to figure this out, what we need to do is we need to use that position of the highest temperature, and we need to use it to index into the other vector. So here I say, from the times vector at row 1, column index, grab whatever time corresponds to that, and that will be the time, not the highest time, because then we just do max of times, and it would be 24 every time, but it is the time at which the maximum temperature occurs, and then we display it out. And here are my results, but again, it's going to be different every time you run it because of the randomization. I don't actually need the 1 comma because it's just a vector, but I thought I would include that. You can specify row 1, even though there's only one row, or you can just not, and you'll get the same result, only when dealing with vectors. With matrices, you need to specify both the row and the column. Continuing on down. All right, let's look at some more randomization stuff here and some other functions related to matrices. All right, I'm going to briefly change my formatting to double-spaced to make it easier to read. I'm going to create a new variable named matrix, and I'm going to put into that variable a 2x3 matrix of random numbers between 0 and 1. Here are the results of that, just some random numbers. You will get different numbers. Now suppose I want a vector of 100 random numbers between 0 and 1. Now what I'm doing here is I'm generating that random vector with 1 row and 100 columns, and then I'm going to transpose it. Now there's an easier way to do this. Can you guess what it is? If not, you can scroll off to the right side of the screen and see. Because, now here's the answer, because transpose swaps rows and columns, this code right here is identical to the much easier 100, 1. Because this specifies 100 rows and 1 column. And there's that displayed out right here. I'll scroll to the very bottom of that. Then I'm going to get the mean or average of the vector. I'm going to put the result into a variable named avg. Make sure not to name any of your variables the same as any functions that you're using. And it gives me a single number. Now if I try and take the average of the matrix, reminder, the average and most other functions in Matlab operate on a per column basis. It's going to get me 3 numbers, the average of each of the 3 separate columns. Continuing on down. And then I switch back to the single-spaced formatting. And lastly, for this randomization video, so I can generate integers between any starting integer and any ending integer I want with the code I demonstrated up above. Well, what about random numbers with decimal digits? I'm going to run this section, Control Enter. And here you can see numbers getting close to -5 and also getting close to +5. And I use those as my lower and upper number. These are just variable names. You can name these A and B, X and Y, whatever you want. I just thought these would be good names. And then this is the line of code that performs the actions that we really want. I again do a subtraction of upper minus lower. Up or high versus low is what I did before at the very beginning. I then multiply by the result of rand. Now that's different from what I did with the integers. Inside the parentheses of rand, I'm still going to specify how many rows, how many columns I want. That you can change at will. I just wanted 10. And then, like before, I'm going to add lower on. Thankfully, I don't need any +1s, -1s, whatever, to make it an inclusive interval. I can generate any numbers between -5 and 5 using this code right here, and they will have decimal values because I'm using rand rather than randi. And then I grab the average right here, and we see that it is in fact pretty close to 0. I mean, there's only 10 numbers, so occasionally we're going to be further off. If I run it again, yeah, I'm much further away from 0 this time. But that's just because of randomness and because my sample size of 10 is very small. I accidentally said I was going to wrap up with random 2 here, but I'm not quite done with the randomness. Let's look at this last section right here. All the previous random number generators, really just randi and rand itself, were uniformly distributed. Another important distribution is the normal distribution or bell curve. Normally distributed random numbers can be generated in Matlab with the rand_n function. The inputs, the stuff that goes inside the parentheses of rand_n, is the same as with rand. It's the number of rows and the number of columns you want, and you're going to get a matrix with that number of rows and columns of random, normally distributed values. Now the default is to use the standard normal distribution, which has an average of 0 and a standard deviation of 1. Scrolling down slightly, if suppose you want a different average, you want your normal distribution centered at 100, for example, then you simply add 100 outside the parentheses of rand_n. This is still going to be 1 row, 10 columns. You can still change those at will. It won't change the average, which will be 100 right here. Let me run this section, Control Enter. Scrolling up, here are my initial random normally distributed values. They are all relatively close to 0. Some might be negative, some might be positive. Here are my random normally distributed values that are centered at 100. Some are above, some are below. I didn't change the standard deviation, so it's still 1. That means that something like 65% of all my generated values I expect to be within ±1 of the average of 100. And like 95% roughly of the values I expect to be within ±2 of 100. 2 standard deviations from the average. Scrolling down. So, okay, well, what if you want to change both the average and the standard deviation? Well, good news, it's really easy. The average is always just what you're going to add. The standard deviation is what you multiply the rand_n by. Here, I'm going to generate 1 row, 10,000 columns of normally distributed data with a standard deviation of 15 and an average of 100. And I can verify that by running the mean function on my resulting vector and displaying out the result. Here, by the way, is another way to display text and numeric data all on one line. We use quotation marks, not single quotes, not apostrophes, quotation marks around our text, a plus sign between the text and the numeric data, and we don't need a num to string. We can just put the number right in there. And then I'm going to calculate the standard deviation of the values in my vector using the very unfortunately named function std. It is short for standard deviation. Again, as always, don't name your variable the same thing as a function when you can help it. So I named it something else, and I display that out right here. And let's finally run this section. Control Enter. All right, my average, very close to 100. My standard deviation, very close to 15. And you might have seen a little pop-up right there. Let's bring it back. A histogram centered at 100 with what looks like a relatively normal distribution. I snuck that one in. The code for that is right below. Right down here, we can specify the number of bins in our histogram. Use the built-in Matlab histogram function, give it our vector of data, the number of bins we want, and it can display out right there. And let's just toy around with this and see if we can get other results. Let's change our average to 50 and our standard deviation to 5. And let's change our histogram to have more bins. I'm going to change it to 20 bins. Control Enter. All right, our histogram looks even more like a normal distribution, that very iconic normal curve right there. Our average is still very close to the average that we gave, 50, and our standard deviation is close to the standard deviation of 5. That's what we would hope for and expect because we used so many random numbers, 10,000 of them. If you use something like 10, well, you're going to get not as good results. Not necessarily as close to the average that you gave. Now, this average is actually pretty close. The standard deviation is a little bit more off, and our histogram looks like garbage. It's still a perfectly fine and acceptable histogram, but it's not displaying the data out in a way that is as clear that it's a normal distribution. But that's just because I changed the sample size to be fewer numbers than I actually have bins in my histogram. So that's just a little bonus introduction to histograms, some normal distribution stuff. That's all for the randomness. I'm going to move on to the further sections in this document in subsequent videos.